what can happen when we roll these dice and flip some flaps. Okay, we are building brain power. We are working with students. We are working on ourselves. We are creating math skills, fluency, and developing things in the way that is missing. So let me show you what we have happening. We have Math Flip Flap Frenzy right here. I'm going to flip my camera around so that Okay, we have Math Flip Flap Frenzy. So we are leveling up our thinking and developing skills from kindergartner age group all the way up to the advanced version with students in the 7th and 8th grade, even up into 8th and 9th grade. 9th and 10th grade. So we have the ability to expand our thinking, reduce this problem that is in America with only 1 in 3 students proficient in math. So this is a tool that I created while I was a teacher, since retired, but just saw the benefits that were developed with the students using this game through their to build their math skills. Now, during COVID, kids were pretty much on their own, and when they came back to school, fluency was something that was missing. So they had a hard time just adding and subtracting basic numbers. And really, basic math is the one that we use throughout our life in every situation. In our life, we use it more regularly than you probably think about. So we are playing a basic version today, what I call the 2-2-1 version. And it's called that because we are using a pair of dice to create equations. So the students or you at home, I love this as a gameplay. I play it with my family or with my mom. She plays with her friends, and we are able to have a lot of fun, work on our math skills. And you know what? Kids love it when their parents play games like this with them because it lets them know that their parents find math important, and they are surprised that parents and grandparents know how to do math. So we're going to do the 2-2-1 basic version, which we are going to create an equation using this pair of dice and an equation using this pair of dice. And then when we roll that, this will be adding or subtracting, and then we add or subtract this pair with this pair. Let's see what we've got. Okay, first player has a 4, 3, a 4 and a 1. So 4 and a 1 paired up against a 6 and a 3. Now I say paired up because we're doing colors of dice. So 1 color plus 1 color or minus. So the 4 and the 1. So on the back of the paper, you'll see here yesterday all of the different options that are created. So really teaching students and yourself to think through all of the opportunities that are available just in working with these pair of numbers. It's kind of where you get statistics, think about us adults playing the lottery, and you got to figure out how many chances, how many combinations of numbers do we have, or think about all the combinations and the variables and stats of let's just say a lock combination. Say there are 4 dials against there. How many combinations can I create from 4, 1, 6, and 3 if I didn't have to do them as pairs? Could I start with the 4 and then do the 1 and the 6 and the 3? Yeah, then I could do the 4 and start with then the 6 and the 3 and then the 4 and then the 3. And then I could do the 4 and the 1, 3, 6, the 4, 1. Okay, and then, so there's so many combinations. So it's really having kids think through combinations of numbers. So we're just adding and subtracting 4 plus 1 or 4 minus 1. So this is going to equal 5, or 4 minus 1 is 3. And then this pair is a 6 and a 3. So 6 plus 3 equals 9, or 6 minus 3 equals 3. So now we have to have a number flip down from this pair versus this pair. So we could say 4 plus 1 minus 6 minus 3. And because these numbers have to stay together, we have to put the parentheses around that. So it's going to be 5 minus 3 equals 2. And we can't do 5 minus 9, so we know that's not an option. Now let's look at this one. We could do 9. We could put the 6 and 3 first. 6 plus 3 minus 4 plus 5. 4 plus 1 equals 5. So 9 minus 5 is 4. We could do the 6 plus 3 and minus 4 minus 1. So now we have 9 minus 3 equals 6. What if we did the 3 plus 5? We could do the 4 plus 1 plus 6 minus 3. So now we have 5 plus 3 is 8. So there are two combinations. 4 things that could be done just by using that pair of dice. So on the front, now they have to look and say, okay, what numbers have I had down before? I don't have a 2, 4, 6, or an 8. So I think I'm going to go ahead and use the 8 today. The 4 plus 1 plus the 6 minus 3. So 4 plus 1 plus the 6 minus 3. So that's going to equal 8. So this player is going to go ahead and put down the 8. So let's see what other options or opportunities are going to be had by the other players in the game. So we have room for 4 players. So if you are joining me live, go ahead and put in the comments if you want to be player 1, 2, 3, or 4. We're moving on to player number 2. And we have the 4 and the 3. So this was 4 plus 3 minus 4 minus 3 yesterday. So we had 7 minus 1 is 6. So that player flipped down the 6. Now today we have a 4 and a 1 and a 3 and a 1. So a 4 and a 1, 3 and a 1, 4, 1, 3, 1. And they're going to create some numbers using the 4, 1, and the 3, 1. Alrighty. Now let's move on to the next player. We're not going to do math for everybody. We're just going to make sure everybody has a number. Yesterday, this player rolled a 5 and a 2 and a 2 and a 2. So let's see what numbers are going to be for player number 3. Player number 3 now has a 6 and a 4 and a 2 and a 1. So they're going to be creating a pair of dice. So 6 plus 2 or 6 minus 2, 4 plus 1 or 4 minus 1 for player number 3. And we'll see what numbers they get to flip down. Do 5 plus 3 minus 3 plus 1 equals 4. Plus 2 minus 2 minus 2. So they could do 6 minus 4 plus 2 minus 1. So this would equal 2 plus 1 is 3. So I didn't have any work done on this player. So now they have done the 6 minus 4 plus the 2 minus 1. So that you say these equations out loud. So this is 2 plus 1 equals 3. The day before, 7 minus 0 equals 7. And then the first one was a 4. 8 minus 4 is 4. So it's very important for students to say their equations out loud. So that player has down a 4, 7, and a 3. Now let's go to player number 4. Player 4 has down, let's see, a 9 and this one is a 9, and then the roll for today is a 6 and a 3 and a 3 and a 1. 6, 3 and a 3, 1. So they're just going to work on some pairs to get those numbers flipped down. So we've done some math over here showing you how the pairs work together. I want to move into our next, the next game that we have is working with doubles, where students are able to multiply, add, subtract, divide. So that'll be our doubles version. Now, this game introduces the mystery cards. So students are able to add a little extra fun to the game by having an opportunity to either draw a consequence card or a bonus card. I guess that's why it's a mystery. You never know what you're going to get. So this score sheet book has score sheets in it for the advanced versions of the game, which are the doubles version, the everyone rolls the same version, extra fun, where we're using exponents and negative integers, and the card version, where students are using a deck of cards along with the dice and adding in a lot of mystery cards. So with this round, we are playing the doubles version, And so far, we are on the 7th roll of the game. Make sure this is right. We have the 4, 1, 3, 5, 8. Okay, here we go. We are using 4 10-sided dice. We haven't introduced the 12-sided dice yet. In fact, on this roll, I was going to change it out to have 2 dice that are the 12-sided dice. So we'll go ahead and add in a couple of 12-sided dice and take those out. Now we have more opportunities of equations because now we've added 2 more numbers that students can add, subtract, multiply, and divide with. So we're going to use the 12-sided dice from here on out for this game. Doubles. So the excellent thing about this game is that with doubles, we are having the opportunity to draw a mystery card. So look at this. This player has rolled doubles. This one was a double-double. Doubles every turn except for yesterday's roll. And today is 2 7s, a 4, and a 3. So a mystery card will be drawn for this player. So player number 1 gets to draw a mystery card. Let's just see what the mystery is going to be about today. So far, no consequences have been given to the game. Ooh, look at this one. A plus B equals 8. You get to flip down 2 numbers that equal 8. Oh, and lucky here, this player has an opportunity to put down 2 numbers that equal 8. The 6 and the 2 are still up. So with this card, they're going to have a bonus by having 2 more cards flip down, or 2 more flaps down without doing any work. So the 6 and the 2 go down. If the 8 is down, flip it up. So the 8 goes up, but the 6 and the 2 came down. So let's look over here. So how do we write this in the scorebook? So if you're a teacher, you need to know how did you get these flaps down, but I don't see any work for that. So you put over here in the mystery card. So you have to write what the mystery card is. A plus B equals 8. And then the teacher, of course, is going to know, or you will know. So it's going to be 6, the 2 down, and the 6 down. So, and then 8 up. So there's the card, and then you take the card once it's done, and it goes right to the bottom of the deck so that you are using the cards more. You actually make it through all 84 of these cards. There is a lot of different things that can happen in the cards. Some of them are repeat, but a lot of them are in there only one time, just to add some fun to the game. Okay, now we are looking at this roll, and I'm writing down the 7, 7, 4, and the 3. Now, since that is done, now I can create my equation. You always have to do what's in the mystery card before you complete your equation because you never know what kind of mystery might happen if you have those doubles. So let's just see what we can do. I can see where I can get this back down to a 7. So I can go 7 times 7 divided by parentheses 4 plus 3. So now I have 7 times 7 is 49 divided by 7 is 7. So that would be, I use multiplication, division, and addition in this equation. Sometimes as a teacher, that might be something you want to require from the students to say, hey, I want to see that you're using multiplication and division, or at least 3 operations in your equation that are different. So that would be the stipulation. Now, what else can we do with this number? We could do 7 divided by 7 plus 4 plus 3. Okay, so that would be 1 plus 7 equals 8. Or we could do the 7 divided by 7 divided by 4 plus 3. So now we have 7 divided by 7, we can equal 1. So you can see the great opportunities that are had in this game, because what if I did this? What if? Because that is the thinking that is developed. That's the analyzing, that's the advanced level thinking that students can do, because now they're thinking about numbers instead of just trying to solve to get the specific answer that is required on the worksheet. They get to determine what the answer might be. Okay, that's enough on this player. Let's move to the next player who had a 2263 yesterday. Let's see if there was any work done for 2263. Yes, 2263 was done, and they just need to put down a number, the 7, the 5, and the 2 are already done, so they're going to choose maybe this one. Let's do the equation that equals 6. So they're going to flip down their 6. 3 times 2 times 2 minus 6. Okay, let's do that. So 3 times 2 times 2. 3 times 2 is 6 times 2 is 12. Minus 6 equals 6. So 3 times 2 is 6 times 2 is 12. Minus 6 equals 6. And players have to say their equations out loud in order to get credit for the game. Okay, so they have a 5, 8, 6, and 2 are done. So their roll for today. Just forgot to finish that one yesterday. They are on this roll. They ended up having a turn skip because they had to trade places with the players. So let's see what the roll is for today. We have an 11. Oh, first 11 of the game since we just added that dice. So their numbers are almost the same as yesterday. 2, 6, 3, except that now we have an 11 to work with. So they have, I could look at this and go 6 times 3 is 18 minus 11 is 7 plus 2 is 9 or minus 2 is, let's see, what did I say? 9 minus 2 is 7. Anyway, they could do, have to do the math. 2, 6, 3. Roll number 5. Make sure to circle that. 2, 3, 6, and an 11. So we have the chance for a, we could do 6 times 3 minus 11. So 18 minus 11 is 7 plus 2 equals 9. If we did 6 times 3 minus 11 minus 2, then we have 7 minus 2 equals 5. So now they have a 9 or a 5. The 5 is already down, so they won't choose that. Let's go ahead and choose the 9, and then I'll write that on the paper in a little while. Now let's go to player number 3. Player number 3 had a 7, 2 3s yesterday, and able to do the doubles again. So that player 2 has their equation done just in case doubles happen for this player. We'll have an opportunity to find out. No bonus mystery card today for this player. So the numbers rolled for player number 3 are 2, 3, 4, 5. 2, 3, 4, and 5. So they'll create an equation using the 2, 3, 4, and 5. Let's go to player number 4. Do we have a 9970 over here? 9970 from yesterday. 9970 for roll number 5. So let's see. We could do 18 minus 10 because the 0 can be a 10. So we have 8 minus 7. Whoops, that's not supposed to be 18 right there. It has to be 9 plus 9 minus 10 minus 7. So 18 minus 10 is 8 minus 7 is 1. So what if we did 9 divided by 9 and say that's 1 plus 10 is 11 minus 7 equals 4. What if we did 9 divided by 9? Oh, yeah, we can't do that. We already did that. 9 divided by 9 plus 7 minus 0, because we can use that as a 0. So now we have 1 plus 7 equals 8. So a lot of chances there. Now this player already has the 8 down, but doesn't have down the 4. So we're going to go ahead and choose 9 divided by 9 plus 10 minus 7. So 9 divided by 9 plus 10 minus 7 equals 1 plus 10 is 11